What are mitochondria and what is their relationship to aging, energy, and ultimately health?
They are tiny machines. We cannot function without them, and when they don't function well, they are associated with disease. Recently, we learned so many more things about how unstatic mitochondria are because they can leave one cell, move to another cell, either to help it or to kill it.
They can leave cells?
Yes, they do.
Are there specific types of exercise that have the most evidence in support of improving mitochondrial health?
We have endurance exercise and we have resistance exercise. The two types of exercise are giving you different things. One, more muscle, so more mitochondria. The other one, more mitochondria because you exercise them and you increase mitophagy and so on. So both. You did not become diabetic until you lose about 80% of the cells that make insulin in your pancreas. You did not develop Parkinsonism before you lost about 80% of these dopaminergic neurons in your brain.
If mitochondria at some point become damaged, what would you say are the chief threats to mitochondrial health today? What are mitochondria and what is their relationship to aging, energy, and ultimately health?
All right. So mitochondria are these small organelles that are in our cells. We have many, many copies of them. 1,000, 1,500 copies is possible. And they came probably from some archaic bacteria that merged with archaic cell to generate what we know now is life on Earth. So all forms of life, almost all forms of life, have mitochondria in them. They are tiny machines that are critical for so many functions of our body that, we cannot function without them. And when they don't function well, they are associated with disease.
Wow.
And you said energy, which is one of the functions that we all familiar with, probably because we learned about it in high school. We also learned that they have a bean-shaped structure from the drawing in the book.
They're little beans.
Yeah, they're not little beads. They are a network that sometimes can fragment to smaller beads, but usually it's very elaborated, dynamic structures that merge and break apart. This process is very important to maintain all the components fresh. So, for example, mitochondria move around cells, small fragments. They meet another mitochondrion, kind of handshake. If the other guy is good, they will merge with it and make one bigger. If it's bad, they will reject it and go. So kind of kiss and run. And this process is very important because components of the mitochondria needs to constantly be renewed. There is no making of mitochondria anew. There is always components that brought by expression of genes in the nucleus, but also by exchanging parts with other mitochondria.
Mitochondria gone wild. Fascinating.
Actually, not gone wild. It's it feels like they're not wearing the textbook of high school, but they do so many things, and they have to have the ability to move around. So, for example, think about a neuron in your brain that's connected to your muscle in the leg, and think how long is an axon. The component of the neurons get all the way to the end. At the end, you have to have mitochondria, and they have to be of good quality. So there are railways that allow mitochondria to moving up and down. Bad mitochondria go back to be destroyed, good mitochondria to come back and replenish it. So they can't be static. Or think about a cut that you got in your finger. Cells need to move and close the gap. Who is moving at the front? The mitochondria. Why are they moving in the front? Because they are kind of like the suppliers for an army goes to the front to make sure that the army is properly energized, has all the components.
Wow. So
not static. And most recently, really recently, we learned so many more things about how unstatic mitochondria are because they can leave the cell, one cell, and move to another cell, either to help it or to kill it. So,
they can leave cells?
Yes, they do. They leave cells, and not only that, that's this kind of studies that are now around for about 10 years start to make us all think about a new treatment in which fresh mitochondria are going to be injected to benefit the body. And in fact, experiments like that have been done in human already multiple times, not in large studies, in which, for example, mitochondria from a muscle in a kid's one part of a muscle of one part of the body, mitochondria are purified from it and were injected directly to her heart to benefit the heart. And it works. They've done it now in 16 kids, and it's really working well. So mitochondria can be donated from one part to the other. And then, maybe the future of medicine, there are quite a few companies that are purifying mitochondria and learning how to store them so they can give it when patients need it.
I mean, you hear fairly regularly about chronic diseases linked to mitochondrial dysfunction. Do you foresee mitochondrial transplantation as a potential therapy in the future?
Yeah, that's exactly what I was talking about. It's possible that mitochondrial transplantation will be a way to help a ill body. Yeah, we have to. There are a lot of still open questions because I mentioned earlier. I believe I mentioned earlier that there are thousands of mitochondria within each cell, most cells except for red blood cells. So if you inject mitochondria, there is no way that you inject enough mitochondria for the whole body. And in these studies in which mitochondria were given, it was surprising to see the health benefit of this treatment. So the question is it because they replenish all the damaged mitochondria, or are they triggering a mechanism that help the body kind of get rid of the bad mitochondria, or are they sending signaling? There is still research to do, but yeah, I think like organ transplantation that sounded, crazy idea and now is a mainstay. I think that mitochondrial transplantation is possible. We just have to wait to see.
Wow. Well, you've alluded to the fact that mitochondria have this very interesting life cycle. So they're not, we regularly talk about lifespan and health span in the context of the organism. But what I think you've alluded to is that mitochondria have lifespans and health spans unto their own.
That's right.
It's very interesting. So, I mean,
also, proteins in your body have lifespan of their own.
It's fascinating.
So, for example, the hemoglobin in your blood cells, once your blood cell is formed, that's it. There is no nucleus there, so whatever you made, that's it. So for 80 days, this protein lives there. But many proteins in our cell have only 24 hours half-life or 12 hours half-life. Some proteins live only for 5 or 10 minutes, especially those that are turn on genes. So, yeah, many things have their own lifespan. And when you talk about mitochondrial lifespan, you're really alluding to something very important, and that there is a renewal, but not biogenesis, not formation of new mitochondria, but there is a constant renewal of fresh components. And one of the things that happens in aging and affecting lifespan is the ability to generate those components start to go down. Not only components for the mitochondria, but those components we really care a great deal about.
So that begs the question then, how do we protect the health of our mitochondria? What are some signs of mitochondrial dysfunction? And also within the context of the mitochondrial life cycle, you hear a lot about mitophagy. You mentioned mitochondrial biogenesis.
That doesn't happen.
It doesn't actually happen.
No, it's not biogenesis. It's the term is just incorrect. There is formation of new parts for the mitochondria, but biogenesis sounds like new mitochondria are formed from nowhere. They're just, it's like changing parts in your car. So changing parts in your mitochondria is something that happens all the time, and you can stimulate it, for example, with exercise. And also, like cars, you repair it, finally it falls apart, so you take it to the recycling center, and that's what mitophagy is. It takes a piece of the mitochondria that is beyond repair, and it goes to the lysosome, the place where everything is broken into its parts, and the components are being recycled.
So you can either essentially rejuvenate a mitochondria, or you send it to the trash bin.
Right. And this process is just so interesting, because who knows what determines whether mitochondria is beyond repair? What's a process that determines it? And there are lots of processes. And actually, we learn much about these processes through genetic mutations that are associated with diseases. And then we try to figure out what was the process. So, For example, there is a machinery that tags mitochondria that are broken beyond repair. So it's like putting, after Katrina, and there were marks on houses to say, okay, we checked and this is now not going to be repaired anymore. Same thing inside our cells that tag mitochondria for irreversible, tagging them as irreversibly damaged. And the same machinery is then recognized by the garbage trucks that collects them. Those are autophagosome that collects those broken parts, brings them to the recycling center, being the lysosome. Sorry for being so literal, but it's really like that. I mean, I have to say that every time in my research, I realized that the world, the macro world, is very much like the nano world. It's the same. There is no magic there. And I remember as a kid seeing Leonardo da Vinci drawing the hands and the blood vessels, and I thought, oh, it looks like rivers, and I was surprised that it looks like, it split into smaller and smaller. Yeah, the macro world is like the micro world, it's like the nano worlds. And if you understand that this is a physical space, your body is a physical space with physical things that are moving around, rather than these two-dimensional drawings that we are exposed to, you start to get appreciation of what can go wrong and how amazing it is that it's working. So
it is amazing.
Yeah.
I mean, we are from nature, and nature is within us. I mean, it's like when you look at the photos of nebulas or whatever. I mean, they look like the eye. They look like neurons. Even here on Earth, you look at riverbeds and the networks that they create, right? It's
And now on Mars, we looked at the signs on Mars, and based on that, we say that there was water there because we see the same sort of. Yeah, so imagine my job. Every day is like that. I mean, almost every day something happens that is like, oh, wow.
It's beautiful.
Yeah.
Tell me about your background. You're a physician, and then No.
I'm, as I say, just a PhD. I'm a protein chemist by training, but I'm curious, so I didn't stay in my lane, and I moved up on the chain all the way to try to get drugs to patients, and I've done it once successfully, once is on its way, so hopefully it will be a second time, but also went to the left to how proteins works with drugs, so going more to chemistry and anything in between.
And at what point in your career did you decide to hone in on the mitochondria?
Okay, so this starts with an embarrassing story. I enjoy teaching, and so at one point, I'm in the medical school. I don't need to teach undergraduate, but somebody approached me and asked me if I'm willing to teach a kind of a introduction class in cell biology to students that might be going to engineering or political science, also pre-meds. So the whole gamut, 240 students in class. So I was teaching it for a while, and every time I will get to the mitochondria, I'll say, okay, pre-meds, open the book, learn all the enzymes in the TCA cycle, glucose comes in, out comes 32 molecules of ATP. The rest of you, nothing really happens beyond that for the many years of science. Let's move to the next topic. I feel so bad about that. It was many years ago, way before what happened to me next, which is my postdoc come to my office with a picture of a brain using electron microscopy, so really zooming on, not even on a neuron, but inside the neuron, and showing me this weird stuff, this 8-figure structure. And I said, what is it? And he said, it's a mitochondrion. I said, no, it's not. Because mitochondrion looks like a bean shape, right?
Well, bean, yeah.
And what are these things that are lumping out of it? And she said, the pathology says it's mitochondrion. In fact, it looks like the mitochondrion undergoes a process that is called fission, but it's excessive. It's become fragmented. So it looks like pathological. It was in a brain of an animal that was hypertensive and had damage, type of stroke in their brain. I thought, how come I can be in the medical school for so many years and be seen a picture and not know what it is? And that kind of got me started. So what regulates fission and what is it? And so imagine that. So mitochondria are more like tube, but it has double membranes. The inner membrane is very elaborated, and the outer membrane is like a sac.
Mm-hmm.
Now it has to break into two. So now think, let's say, if you're making something from dough, you kind of pull on it, and then eventually you can get two pieces, or you can cut it with a knife. The problem with cutting a tube with a knife is that you spill the content. The problem with pulling it is that you might not segregate bad components from good components. So here is what nature devised. There is an enzyme called dynamine-related protein 1, never mind the name, swimming around in the cell. When mitochondria needs to be cleaved, it goes from a state like this to an extended state. It kind of unfolds. At the head, it has this engine, and the rest is like a rope. Now, one rope is not enough, so they create a kind of a line of ropes next to each other, and then they squeeze the mitochondria into two. What's amazing is when it's normal, it's squeezed to two equal size. But when it's excessive, it keeps chopping from the edges. So what we saw is this machine that is doing it. So I said, how does it know to get to the mitochondria, and where does it bind? So that started my research, and that eventually led me to discover, luckily because people didn't pay attention to that side of the business, that there is one partner on the surface of the mitochondria that its job is to bind this protein, dynamine-related protein 1, when the mitochondria is damaged. This protein then binds to it, and now you have excessive fission. And if it goes too long, too far, eventually all your mitochondria are broken down to small pieces, and that's disease.
Does that have any relationship with cancer?
Yes. But can I step back yet? Because
Yes.
I'm still interested in the brain before I'm interested in cancer. So in the brain, I told you about these hypertensive animals that had broken down mitochondria. So we were interested to understand whether inhibiting the interaction of this protein in the cytosol, in the milieu of the cell, going to the mitochondria, if we inhibit this interaction, can we prevent damage? Why is breaking the mitochondria into small fragments is bad? So first of all, we discover when they are broken down to small fragments, they don't have all the components in them. And so instead of making, for example, ATPs, they start to make reactive oxygen species. So bad mitochondria create more bad. The other thing is that in the brain, when the mitochondria are very fragmented, they cannot really go up and down the railroads. So that's also bad. At any rate, so we decided to see if we can inhibit this interaction, what happens in animals that have neurodegenerative disease, for example. So initially we did it in heart attack and in stroke, but eventually we went to chronic disease that also have fragmented mitochondria. And we identified how the two proteins interact with each other and made an inhibitor of that interaction, which we called P110. It's a boring name. It happened to be the 110th peptide that we made throughout my career for a variety of things. And that peptide inhibits the pathological fission, but not physiological fission. And when we gave it to animal, it slowed down death from ALS, from Parkinson's disease, from Alzheimer's disease, from what else?
Alzheimer's, Parkinson's, ALS, frontotemporal
many
dementia,
other things.
vascular dementia.
Yeah, and also importantly,
Lewy
we gave the inhibitors to many other researchers just for the own as a tool, and they found that it inhibits many other diseases that tunnels into this excessive fission.
So
it's not just
let me see if I understand it. The protein P11,
the peptide,
the peptide,
P110,
basically inhibits the dysfunctional fission of these mitochondria.
Right. And through that, regardless of the cause of the disease, you slow down downstream damage from the disease. So, for example, Huntington's disease was another disease that I blocked. Was the first one I
was going to say that, but I know that that's like a genetic thing.
There you go.
Yeah.
So it's a genetic disease. There is neurodegeneration, death of neurons. There is neuroinflammation, inflammation in the brain. But the disease is caused by a genetic mutation that causes aggregation of proteins, a protein actually specifically called huntingtin. How inhibiting excessive fission prevents or slows down Huntington-induced death in these mice and neurodegeneration and neuroinflammation? It's surprising, which surprised us as well. And we can't say that we understand all of it, but one logical aspect is coming back to your first question, which is mitochondria are doing a lot of things that are essential for the repair of the cell. In fact, it's very important to realize that we need to give mitochondria time to do the repair because that's part of their functioning. So repair means generating building block to the components, generating the right neurotransmitters and hormone, getting rid of toxins. So if you have toxin accumulating in the cells, you have to get rid of them. And of course, subdue the inflammation and fight viruses and so on and so forth. So by making the mitochondria healthier, they can help the cell, and therefore they can have organ, help the body.
Yeah, and wherever that mitochondria is, in whatever cell, in whatever organ it is, I mean, it's basically helping the cell do what the cell is meant to do, which in the testes could be creating sex hormones, in the brain could be facilitating thought.
But the jaw-dropping things that happened in the last 10 years and is what I started with, the understanding that the mitochondria in one cell are not necessarily working only on the cell within which they reside. They can, first of all, send components that help the other organs. So we call them little treats. They are short peptides that are generated by the mitochondrial DNA itself, or they can trigger other processes that help other cells around them and also their own cells do better. But they can also get out, which brings me back to your cancer question. You want cancer answer? Mm-hmm. Okay, cancer is really complex.
Well, it's just when you mention the uncontrolled fission of these organelles. I mean, my very cursory understanding of the etiology of cancer is that it's like the uncontrolled reproduction of cells, right?
That's correct. That's correct. So definitely that's the definition of cancer. That the cell becomes totally egocentric, just doing what it wants, divide. It doesn't listen to the surrounding. No, stop. You are pushing on me. No, you're eating my ingredients. Stop.
It becomes egocentric. Wow.
Totally. But it does so much more. So in the last few years, the kind of things we learn about cancer and mitochondria are just mind-boggling. So first of all, cancer cells sit there, in come a T cell, an immune cell, to kill it. What does this bandit do? It sends a nanotubes and siphon out mitochondria from the immune cells into itself to give itself the components that they need, and weakening the immune cells.
That's what cancer cells do?
Cancer cells do that.
They send a little tubule and siphon out.
There you go.
The important machinery.
And there is a picture in the book showing it because I didn't believe it until I saw it.
Devilish little bastards.
Not the end of it. It has its own bad mitochondria. What does it do? Inject them into the cells next to them, especially immune cells. So give them bad mitochondria. Not only that, they put on the bad mitochondria kind of an invisibility cloak. So it covers it with some things that cannot tag the mitochondria as bad mitochondria to be destroyed. This is really major devilish design.
It reminds me of mosquitoes.
Yeah.
Worse. Mosquitoes, they inject their little whatever the hell you call it.
Well, they want to prevent your blood from clotting so they can suck more blood locally.
Bastards.
But the body doesn't like it, so it responds to it. But here, there is another mechanism, not the end of it. So mitochondria are needed to convert glucose into ATP. If you don't use the mitochondria, you generate ATP faster, but you're wasting most of it. So it's 100 times faster to generate it through glycolysis. So tumor cells switch to glycolysis, but they need the mitochondria mainly to produce all the other things that they do. When we try to find cancer in the body, we use this to our advantage because these cells need glucose. So we can use glucose as a way to mark this is a cell that is dividing very fast and uncontrollably and using glucose instead of the normal metabolism. So that's how we can find metastases. But then come again the bandit with a new trick. It switches. So recent studies showed that the same tumor sent metastases, and they used different carbon source in the new places. And then the bandits also use the neurons in our body to find places to grow and steal mitochondria from the neurons, and on and on and on. So you can say, okay, this is just too much for me. How do I deal with it? But actually, every single finding makes you start to think about, okay, here is a trick for which I have an antidote. So for example, if they switch to different carbons, okay, now I'm going to look for them using different carbon source. Or if they depend on certain interaction with certain cells, can we interfere with that? And so on. So I'm very optimistic. I think that everything that we learn is, first of all, it's like, amazing. And then after that, okay, if it's related to health, how can I take care of it or use this information to generate new tools?
So when glucose ceases to be available for the cancer cell, will it then go to fat as a fuel source?
Fat, I haven't seen.
It's just looking for carbons.
They use, exactly. So the TCA cycle, this conveyor belt in which glucose breakdown, pyruvate and acetyl-CoA are going around. There are all sorts of intermediates. And so what it does is it starts to use different intermediates. So for example, it will use pyruvate or succinate, which is downstream from it, and so oxalate and so on. So it doesn't invent new tricks. But before we move, I want to make sure that I don't forget to say something important related to mitochondria and disease.
Please.
So you see all these things and you can start to think, oh, mitochondria are cause of the disease. And I want to make sure that people understand that there are some mitochondrial diseases. But what I'm talking about with mitochondria is another player in propagating the damage. And how, by taking care of the mitochondria, we can provide an organelle that can help repair or address the damage that is occurring either because of your genes or something else that has happened.
Well, how much of a role does environment play? Because I guess that then brings me to the next logical question is like, if mitochondria at some point become damaged and there's this uncontrolled fission that is then initiated, what would you say are the chief threats to mitochondrial health today?
The chief threats are all known to all of us and few hidden ones. The first one is pollution, air pollution, but also radiation, which we all know. But then barbecued, burnt food, burnt oil, damaging mitochondria. Sugar at high level, damaging mitochondria. Not sleeping enough, not exercising at all. But then we can turn it around and say, here are a list of things that by small lifestyle changes you can address. And the good thing is that you don't need to be perfect in everything to improve the situation. So, for example, if you really have problem always sleeping, there's some people who really struggle with that and they cannot solve it, and experts cannot help them. There are other things that they can do. Not being stressed, enjoying life, having laughter, spending time with friends, running, eating properly. There are other things they can do to help the mitochondria. And the reason for that is that what we call the threshold effect. Our body is pretty amazing. You can beat it and beat it and beat it, and it's fine. And then suddenly you just one more time and it's falling apart. So you can look at it and say, how can I know that I'm at the verge? It's a cliff. Or let's not play with it and pedal back as much as we can all the time. Because aging is a process in which we come to that cliff anyhow. So the more you take actions, more likely you keep your mitochondria in better shape, so it help your cell, help your organ, help the body, help you.
Now, are there actual human, maybe you can walk us through what the human clinical data looks like of, I don't know, Are there twin studies, for example, where you take people with the same genes and you put one on, one lifestyle, another on a control lifestyle, and then you actually look at the health of the mitochondria of each twin and compare them? Do those kinds of studies exist?
Yeah, I don't know too many twins who will be willing to participate in a study like that, but sometimes it happens anyhow. So there are studies, for example, of twins that were separated at birth, and sometimes they are subjected to different environment, and you watch what happened to them. Or one example is the Kelly twins. One went to, both of them are astronauts. One spent more time out, I think, a year, and the other one stayed on Earth, and you can look at the difference. And you can definitely do studies like that in animals where you ask whether the genetics is a determinant or the environment is a determinant. And the short answer is it's both. As, by the way, most of the answers in my book, in our books, that it's both. But the way, so some studies in which twins were separated and that they lived in different parts of the world, you see that they have, for example, the same type of obesity or the same types of likeness or not likeness to preference or not preference to be athletics and so on. So there are definitely genetic determinants in everything, but pollutions or other environmental factors definitely play a role. So if you have the city mouse and the country mouse, are there going to be difference? Perhaps based on the environment. I think the huge studies on twins were not yielding kind of, this is one factor that is causing it. But lots of epidemiological studies start to show us what correlates, and then we can start to think about studies that will show causality. But causality is always harder.
It's always harder to arrive at. We're spending a lot of time these days talking about what the actual needle movers will be when it comes to making Americans healthier again, but ultimately people, no matter what country they live in. And there's some shocking statistics, today with regards to obesity. By the year 2030, 1 in 2 adults in this country are going to be not just overweight, but obese. And I came across some really startling statistics that I'm not sure how high quality this data is, but it estimates that in North America and in Europe, the average calorie consumption for adults is about 3,500 calories, and fewer than half of the adult population gets the recommended 20 minutes a day of exercise.
So 75% don't, yeah.
Yeah, it's crazy.
Yeah.
So, obviously we can break down diet into myriad, we can, slice it into myriad different components. But from just the standpoint of energy excess, what effect is that having on mitochondrial health?
Okay, so the answer to that is clear. All the things are bad for the mitochondria and therefore are going to be bad for the people's health, no doubt about that. But if I can turn around your question is how in an era of access can we bring people back to thinking about their own health and what's in their control? I would say that you watch a movie in the 50s, so on one hand, you see them smoking like mad. On the other hand, they are all thin. Men has a waist like this. It's striking. They also don't have any muscle. They are very, very thin.
Yeah, they're like skinny fat almost.
Yeah. So you see that what we are doing to ourselves. So having muscle is good. Having fat to the excess is definitely not good. Smoking is bad, so not smoking is good, and so on. What I'm trying to say is there are lots of things that one can do. And part of the reasons why people are kind of giving up on that, I think, is that not having a sense of control. So what I try to do and what we try to do right in the book is how much control you do have. It's true that lots of things are not in our control, but there are things that we can do to take care of the mitochondria so they will take care of us. And we don't need to do all of them, and we don't need to do all of them all the time. So, there is clean eating, right? So you always have to eat the right food. And God, if you sinned, God forbid, you're really stressing about it. This is an example of a good thing that turns bad because you went to an extreme and you are stressing yourself about it. Stress is also bad for your mitochondria. I guess what I'm trying to say is that realizing, getting the education of why the things are bad is part of the things that we have learned recently. And I think that lots and lots of people start to hear it. We try to impact kids in school about that. At the same time, if they start on acting on these things later in life, when they realize there is consequence to that, they still have a chance to reverse a lot of that. There is some sense of control over it, and so people like to feel sense of control. But eventually, there is also the genetics and other factors that are not in one control.
Yeah, there are definitely aspects of health that are outside of one's control. I mean, I know that, better than most. But so, let's get actionable for a moment. Are there specific types of exercise that have the most evidence in support of improving mitochondrial health?
The answer is both. Okay, so the answer, and also Goldilocks, not too much of anything. So, it's the same answer for all the lifestyle changes that one can do. So what do I mean by that? So we have endurance exercise and we have resistance exercise. With resistance, you're building muscle. If you build muscle, the muscle have lots of mitochondria, so you build more mitochondria, so more guys that can send around good treats. With enduring exercise, during exercise, the electrons that are supposed to go through this chain to generate eventually ATP are leaking always. About 5% of them also are leaking. Leaking. And when they leak, they make what we call reactive oxygen species or oxidative stress or free radicals. And those are very interacting molecules that cause damage. And so we thought for a while, let's take all the vitamins that we can to completely eliminate ROS. No, those ROS are good. During exercise, the ROS are telling the nucleus, I've been working my tail off. I may need replenishing of parts because I burned them out. So get going, synthesize them, or start the signals to synthesize them. So you generate better, fresher mitochondria, which is always good. So the two types of exercise are giving you different things. One, more muscle, so more mitochondria. The other one, more mitochondria because you exercise them and you refresh, you recycle, you increase mitophagy and so on. So both.
Both resistance training and
not too much, because if you do too much, then you cause damage. So definitely in resistant exercise, you know that you can hurt your back, you can pull a muscle, you can break something, right?
Oh yeah, I know.
I know you know because I've been listening. But
story of my life.
But also in endurance exercise, running too much makes enough ROS, and people that have a genetic predisposition to ALS, to Lugavere disease, they have more ROS that can actually trigger the disease. And we know that quite a few, this is a rare disease, quite a few of the subjects that have the disease were famous athletes. So
now, how do you know what too much is? Like
if after we asked exercise specialist in that, and one of the things that she said, if after you exercise, you always feel that you're exhausted and you're more likely to get a cold and you're in a bad mood, just listen to your body. You know that. And by the way, if you do weight and it really hurt, listen.
Yeah.
Don't go through that. Oftentimes you hear trainers that are with good intentions saying, no, go through that.
No pain, no gain.
Yeah, exactly. There are studies that showed, for example, that 20-year-old young men in the army went through a grueling walk, many kilometers, taking with them a weight that was equal to their body weight. They've completed this grueling exercise. They had lots of damaged mitochondria. They also broken bones and damage to their kidneys and so on. There is no longer used as a way to train soldiers for that reason. Too much is bad. Too little is bad.
Yeah. It's always shocking to me. It's just so counterintuitive when you consider that sedentary behavior is actually a stressor, a cellular mitochondrial stressor. Because it doesn't feel like stress. It feels like the opposite of stress, when in fact it's very stressful from the standpoint of
just being sedentary.
Yeah, I'm not talking about taking a rest day or relaxing after a long day in the office. I'm talking about chronic sedentary behavior, how stressful that can be on the body.
Yeah, it's depressing. It's lack of interaction. But I want to tell you something about exercise that's probably not intuitive to you, or maybe intuitive, but you're not acting on it. So we spoke with a researcher that is very interested in watching behavior, exercise practices, and mobility also in tribes elsewhere where what available is not a gym, but actually. And he would go in Africa to visit a tribe there, and everybody would be sitting down. The children would be sitting down. Everybody is sitting down. Nobody is exercising. Nobody is moving unless they have to do something with it. So preserving energy was a way we had to act so that we can use the energy when we need it. Now we go back to the axis. We live in such an axis. So for us not to move is really bad. They are moving, but they move when they need.
But also their diets are probably way lower in terms of calorie density.
Absolutely. And not ultra-processed food. And yeah, absolutely. But they do eat barbecued things or burn things on the fire, so they do expose themselves to bad things like we do.
Would you say that ultra-processed foods are uniquely harmful from the standpoint of mitochondrial health?
Uniquely harmful. Yeah, I would say I'm trying to think about anything else. I think uniquely harmful to the mitochondria and also to your microbiome, both. Why is that? Because it's rich in compounds that are aldehydes, so they by themselves cause damage, or are this carbon source that are causing what is called age. So interaction of sugar and the like onto macromolecules, both are harmful.
Age, those are advanced glycation end products.
Right, exactly. And those are, they don't require enzyme to be put on, and so there is no enzyme to take them off. And that's part of the reasons why that is, until the protein is going to recycling, it's going to hang around.
Man, so they're aptly named.
Yeah, isn't it?
Yeah.
The age in aging.
The age and
also in people who are diabetic, yeah.
What about specific foods or nutrients that might benefit mitochondrial health?
Okay. Let me start with the one that I was clueless about, which is eating lots of fibers. So we are told correctly that we need to eat much more fiber. In fact, we both thought that we eat plenty because we eat large salads every dinner and lots of fruits and vegetables. So now we were doing better. I thought that it is good because it gives vitamins, or most people think that it's because it makes you regular. But I discovered that one of the key things about fiber is actually feeding your bacteria to generate butyrate, which feeds the mitochondria in the lining of your colon. They do not use glucose. They use butyrate, which is a short-chain fatty acid. And they get it from the bacteria that is sitting outside the wall there. And importantly, if they get it, they generate enough mucus kind of layer there to separate the bacteria, the bad and the good bacteria, from ourselves. And so if you don't provide enough fiber, the bacteria start to munch on this layer that was supposed to be thick, and now it's thin. So there's research showing it very well in mice, but also in human. When you do endoscopy, you can measure the thickness of this layer, and it's very much dependent on how much butter, butyrate, your bacteria gave you as a result of you feeding them with a fiber. Okay, so that's the surprise one. And then the usual ones, eat your vegetable and fruit because you get your vitamins from that. Vitamins are these micronutrients that are very important cofactor for enzymes that are working inside the mitochondria, also elsewhere, outside the mitochondria as well, but many are needed for the mitochondria. And the best way to get those vitamins is when they come together with other ingredients in the food. Supplements, when they are given separately, they don't seem to be as good. And also there is always a risk of taking too much of any of those vitamins. Like everything else, too much of things are not good. And then there are also other things that we need, which is minerals that we also get from our food. So eating, balanced diet is the best way to take care of your mitochondria. Feeding them will take care of us.
And a nutrient-dense diet as well.
Yeah, diverse.
Yeah.
Yeah, not homogeneous. So, there are craze, only grapefruit or only cabbage soup, and you'll live forever. Well, you are likely to lose weight because you didn't get enough of everything else. But it's definitely not good because you don't get all your vitamins, all your minerals from this. And also, gosh, it's so boring. I mean, if we draw pleasure from eating, that's by itself good for our mitochondria because being in a good mood, enjoying yourself is good for your mitochondria.
I like that, the mind microbiome axis. Is it's fascinating. I've done definitely a bit of reading in that arena, but the fiber stuff is fascinating. And that, correct me if I'm wrong, but doesn't that come from your neck of the woods? That research, the Sonnenberg lab.
Sonnenberg's, we went to talk to them, and that's when I discovered that Erica was a student with a good friend of mine that used to work, and we both used to work on a completely different field. And she was one of the students I remember when I visited my friend that she was there, and now she is this well-known professor on microbiome, not on,
so cool.
And they're just lovely people and also taught us a great deal.
Yeah, incredibly important work that they're doing. Are there any specific vitamins or minerals that you think we might be overlooking with regards to mitochondrial health? I mean, magnesium is just something that comes to mind because it's involved in so many, processes in the body. And one of those processes, which I often cite, is ATP synthesis. Any specific nutrients of concern, nutrients that we know that Americans aren't getting enough of today, for example?
Well, first of all, vitamins, minerals aside, vitamins, and you're right about magnesium and calcium and so on. Vitamins fall into two categories, water-soluble and lipid-soluble. So water-soluble, you eat them today, they're gone tomorrow. You pee out the extra, and so those are vitamins that you need all the time. Those are the B vitamins. And there is B1 to B12, but actually there are only 8 or so, something like that. Some of them were called vitamin, and they discovered they were
are
not.
no longer. Like choline. Choline, I believe, used to be a B vitamin.
I wouldn't know. I was not an expert on nutrition before I started. We started to work on the book. Vitamins and vitamin C is also water soluble. The vitamins that are lipid-loving, hydrophobic, oil-liking, like A and D and E, those are long-lasting. But they long-lasting in the sense that they stay in our body for a long time. So if you take excess or too little, there is a consequence, but it's not something that you have to consume on a daily basis. But they are very important for our body as well. So if you ask me one vitamins, I have a new favorite because I started to work on a family of enzymes that relate to detoxifying the mitochondria. And one of them is an enzyme that is completely neglected, kind of very little research on it. And so, of course, I like it. And that enzyme is very much dependent on vitamin B6. In fact, when it's malfunction, it consumes vitamin B6. And B6 is a vitamin that is required for so many reactions. So deficiency in B6 is really bad. But recently, because people heard that, they start to consume large amount of B6, and that's also bad. It causes a neurotoxicity. So again, kind of like Goldilocks effect. Not too little, not too much. And I think that there is a reason why the FDA says, 100% of a vitamin. So if you take a drink and it said 2,000%, you might want to think, do I need 20 times higher the dose that is recommended? Is there a reason for that? And vitamins are so easy to detect. You go to a clinical lab and you can find out you're missing B12 or you're missing B1. Then you can take supplement. Like I was missing vitamin D.
You were.
Yeah, and I shouldn't be because,
D is an important one, yeah.
Very important for my bones. Yeah, so.
Amen.
Yeah.
Are you at all familiar with, have you come across Urolithin A?
Yeah.
At all? Yeah, tell me about that. Because, I mean, it's now on the market. There's a supplement product. We've worked with them. It's called Urolithin A. It's called, MitoPure. But what is the truth about Urolithin A? I mean, when I initially stumbled on the research, it was very exciting to me because it's this postbiotic that many of us make in our, colonic gut ecosystems when we eat certain phytochemicals. And the promise of Urolithin A, which is why I bring it up, is that it's thought to stimulate mitophagy. It's
thought to do quite a lot of wonderful things. And we spoke to researchers that use it in their research. I'm working on a particular research problem, especially in Switzerland. There is a large group of people because one of the scientists that start to be interested in that is Swiss. And they are amazed by what it does. I also have a colleague who is a physician who uses it, takes it for himself. So it could be a fad, it could be true, but I can say that in animal model, everything that I see about it is really interesting. But one key component that many people kind of overlook that I haven't seen yet an answer to relates to whether we can metabolize, absorb, generate urolithin A naturally. So it's made in the gut by the bacteria. And some of us don't have the bacteria to make it, but many of us do. And urolithin A can be generated from walnuts, from grapes, from pomegranate, famously from chocolates. Orange chocolate is another magic one. So perhaps the first thing we need to do is check our microbiome and find out, do we have the natural bacteria to make it? And if we do, then why should we take a supplement for which we already generate enough? And is there a possibility that too much of a good thing is a bad thing, which I haven't seen data for. So my point about that is that initially there was a study that suggested that it's very rare to have the right bacteria, and then there was another one that shows that actually quite a few of us have it. Just leaving it out there, I just don't know.
Yeah.
But I can tell you that a physician friend of mine that I trust says that he takes it. I don't know if he noticed a difference or not.
Yeah. And then the question arises, like, even if you do have the bacteria required to create this postbiotic compound, like, are you actually eating enough fruits and vegetables? And the data suggests, like, most Americans aren't.
Which you should, walnuts, you should eat walnuts or other fruits like pomegranate or the like. Yeah. So that brings you back to diverse diet. And those are the things that we know. And how many things we don't know, and how many things are around the corner, and tomorrow I'll find out and say, oh, I should have told that to Max. That's why what I do is so much fun.
So much fun, yeah.
Yeah.
And I get to talk to fascinating people like you, which makes me the winner here, actually. I want to ask you about, because, mitochondria, you'd never, it's kind of a good day, actually, when you go on X and you see mitochondria as a trending topic on X, formerly Twitter, right? But mitochondria have sort of entered the public zeitgeist recently because it's become, a bit of a talking point for our Secretary of Health and Human Services, RFK Jr. And he said recently, which he was lambasted for by, depending on which side of the political aisle, you happen to be on, but I thought it was a really interesting quote, and you're an expert in mitochondrial health, so I want to get your thoughts on it. So he said that I'm looking at kids while I walk through the airports today as I walk down the street, and I see these kids that are just overburdened with mitochondrial challenges, inflammation. You can tell it from their faces, from their body movement, and from their lack of social connection. And so now we have some people, because of his obvious affiliation with the current administration, calling mitochondrial health a fad as a result of that, which is really kind of sad, right? But or good, maybe, I don't know. Or maybe there's maybe there's a charitable way to look at what he said. Or what's your take?
I think that first of all, every time you bring awareness to something that is actionable, it's not bad. The question is what action are you taking? Who are you taking? Based on what advice are you taking them? So, aside from current source of information about the mitochondria, no, I don't believe that if you see a child, you can say whether the mitochondria are functioning well or not. If he was trying to say that if the child is obese or the child is depressed, it means that he's not doing well, and possibly the mitochondria are not doing well, possibly. I wish we had a way to measure mitochondrial function quickly by looking even better, but by even a device on our body. At the moment, there aren't good devices like that, so we can't tell. And a device like that would have been ideal, because if you change something in your life, you can get immediate feedback. Oh, this is good for mitochondria. Oh, no, this is not good for my mitochondria, and you can correct. Hopefully, we'll have something like that. So what happens when you get advice from influencers to do something? You have to take it with a quart of salt. You know, we have a very short paragraph about thinking like a scientist. So it's actually a very simple way of kind of sorting the information that you receive. What's the authority of the person that said it? Based on an observational science or actually experimental science? Was it done in animals or in human? If it was done in human, was it a tiny study or a real big study? If it was done on human, is it a human like myself? So, for example, if it's a study in young men, it's not relevant to me. And this active thinking about it is important. But then where eventually you can get advice, especially now since some of our government healthcare maven became a bit political, is to look at a source of advice of like American Association of Physicians or pediatrics and so on. So you look for authorities that you trust, and of course, if you trust your physician, that will be the best way. Not taking it from social media or from a guru, even though their intention could be good. Now, bringing the word mitochondria to the forefront, if it's not a political statement, sure.
Yeah, I think it's great.
Yeah.
Yeah, I would have to agree. I think, obviously it's impossible to diagnose somebody with mitochondrial dysfunction when looking at them, right? But taking a more charitable lens to what he said, 20% of children today are obese, and we are seeing conditions that were, historically predominantly diagnosed in adults now creeping their way into the younger population in this country. Hypertension. Diabetes, yeah. And these are conditions that are associated, right, with mitochondrial dysfunction.
That's right.
So it doesn't take like a huge stretch of the imagination to say, okay, there likely is, some mitochondrial dysfunction going on there. But
that's why I didn't say it's baloney.
Yeah, it's not. Yeah, I would agree with that. And I also don't think that like his words were necessarily meant to be broadcast to the lay public. I mean, I think he said this during a Senate hearing or something like that. But at the end of the day, if he's getting people to be more cognizant of what mitochondria are, how they might be, playing a role in health and longevity, to pique curiosity, especially now when we have tools. All of us have tools at our fingertips to quench that curiosity. AI, Google, I think that's a positive.
You know, when people now many years ago were saying that any news about them is eventually good, regardless if whether it was initially a bad story, because they
All
will
press
remember
is
the
good
name.
press.
Yeah, exactly. You forget what was. Maybe that's what will happen. But it just bringing it up to the front is a good thing.
Yeah, I would agree with that. Man, we didn't get to. What is Mitochondrial Eve?
Ooh. So imagine how old I am, because I was in a lecture in a retreat at Berkeley when Alan Wilson and his student or postdoc, Rebecca Kahn, were talking about that. And I remember the moment. It was mind-boggling for me. First of all, I learned that we inherit our mitochondria only from our moms, not from our dads, which, by the way, always bothered me because I know that the sperm is full of mitochondria, and how come the mitochondria don't survive it? So if I remember, I'll go to that as well. But I'm answering your question first. So if we get our mitochondria for our moms, if you sequence the mitochondria, my mitochondria should be very similar to my mom, should be similar to her mom, her grandma, and so on and so on. So eventually you can look at how all the mitochondria in various geographical ancestry groups relate to a single person. In fact, to about 6 or 7 women, something like 200,000 years ago. So hence came the expression mitochondrial Eve, that there was a woman.
One
in this
woman.
Case, well, it's not one woman, it's probably a bit more. And the rest of them existed, except that they didn't survive in evolution. So there were many female 200,000 years ago, and only the most fit survived. Okay, so quite a few more things about it. First of all, if I had my kids in my 20s and my daughters had their kids in their 30s, how come the mitochondria in their children or in my daughters were in good shape? Because I was then 20-some years old. All my mitochondria were beaten all the time. How come the mitochondria remained pristine or relatively pristine? That was a discovery of a young Turkish scientist that lives in Spain, that discovered that actually the mitochondria in the egg are turned off. The complex one is inhibited, so they work very little, and so that's how they keep it pristine. And that's why my mitochondria are identical to my great. And also yours, like your mom and her mom and so on. So that's one thing, which means, another thing. So could infertility sometimes be a disease where the mitochondria in the egg forget to turn on? And can we fix it? So that's kind of, here is information about mitochondria Eve that you continue to research, and suddenly you realize, there is a utility in this information. So good place for me to say, that's why fundamental research in academia is very important. It's important for us to continue to tinker, because then when we tinker, we start to understand how things work, and therefore when they break apart. So. And then to the last thing about, there are many more things about that, but the last thing that bugged me is what happens to the male sperm, especially when you have in vitro fertilization where you inject the sperm into the egg. What happened? So there are a bunch of theories, one of which is that the mitochondria in the sperm, they are so you know the shape of a sperm, the head. Then next to it, there is a spiral of mitochondria, and then there is a tail that is moving and allowing it to swim straight. It swims a long distance.
It requires a lot of energy.
Yeah, the mitochondria work hard. They come already to the egg. They are marked because they did all this work. They had a lot of Ross. So, that explains what's going on in normal fertilization. And what happened in vitro, first of all, they also worked. They had to get to where they got. But also there is the theory, remember that we said that the mitochondria came from this ancient bacteria, that like bacteria, they know their own and they know foreign. And since they were the majority, maybe there is a mechanism that makes sure that they get rid of. So almost all people have zero mitochondria from their male, but once in a gazillion years it happens.
Very interesting.
Isn't it?
So we inherit it from our mitochondrial DNA from our mothers.
Mm-hmm.
What impact, if any, then does it have on the heritability of disease? Curious, because in my case, my mom, her health was not great, but her mother's health actually was good, and my maternal grandmother lived a very long time. But my mom's health was very poor, and she died very young, relatively young.
Always hard.
Yeah, very hard. But so me and my brothers, we obviously inherited our mitochondrial DNA from my mom. She had a condition that that for all intents and purposes has mitochondrial dysfunction, or is at least related to it. But I'm assuming that, all health outcomes are, as you stated earlier in the show, are some relationship between genes and, environment. So yeah, what is that relationship like? So
obviously, first of all, I'm not a physician. And also, obviously, I don't know exactly what your mom had, but let me kind of use it as a way to start to explain what can happen. How can a person that have a certain genetic predisposition or exposure in utero or throughout their life to something that, how come they can have children with normal outcome or with good health, in your case. So it could be a combination, since we inherit many genes from our father and from our mother. And by the way, the mitochondria itself has only 13 genes, and then some short peptides that are very important. But it has maybe 1,000, 1,200 different proteins that come from the DNA in the nucleus. So all these are coming from both parents, and it could be that your mom inherited copies of a problem on the same protein or in two different proteins that complement each other, and as a result of that made her more sensitive to something else that happened. So it could be 3 causes, 2 causes. And you luckily had also your father, so you're not identical to your mom. You're not identical to your siblings, because at random, some genes are left dormant and the other ones are being used. So all this can explain how a person who is not healthy can give rise to healthy kids and vice versa. But coming back to mitochondrial disease, primary mitochondrial disease, in other words, damage in the mitochondrial DNA. So a woman that is healthy can give rise to children that are having mitochondrial disease. It's expressed itself. Something is ringing. It's expressed itself later in life, and it's slowly causing deterioration of the child. And this has to do with what is called heteroplasmy. So a mother that has a primary mitochondrial disease can be healthy, has no disease. One of her child can have this primary mitochondrial disease and the other one is not. Why is that? The phenomenon is called heteroplasmy. The mother didn't have any expression of the disease because the majority of her mitochondria were normal. And we have huge reserve. In fact, we have to have damaged mitochondria, at least 60% of our mitochondria to be damaged, some say even 80, before you see any phenotype. So if we can pause for a second, this is kind of a general message. If we have reserve, that means that we can just keep away from this brink and then stay healthy. So if you continue to push towards health, you are away from the brink. And that means simple change in lifestyle. Okay, so this woman has some damaged mitochondria and some normal DNA in the mitochondria and some normal. This heteroplasmy plays a role in each of her mitochondrions, each of the elements, so that she can have 1 or 2 or 5 of them damaged. That's about the number of DNA there. Now, this single egg had some damage, some normal mitochondria. and they start to divide into cells. And at random, some damaged DNA is segregated to one cell and others are not. If a lot of them are segregated to one cell, and that cell becomes, let's say, part of your heart, they will develop a heart disease earlier than if the majority were normal. So you can have, even in the same body, somebody that has primary mitochondrial disease that express itself only in the skeletal muscle and not anywhere else, and some that will have systemic. And it's just this random segregation of the bad and the good mitochondrial DNA that causes this. Is called heteroplasmy.
Heteroplasmy.
Yeah, so they're not all identical.
But I mean, it just goes to show you genes are not destiny.
There we go.
Made me think of like an airplane, you know, like how there's so much redundancy built into the complexity and all the myriad systems that make an airplane fly, that if something were to go wrong, I mean, there's like 2, 3 backups.
That's what I tell people that tell me that they have a fear of flying, because I love flying, especially taking off. It's like, whoa, I love it. So yeah, if people who have fear of flying is a good thing to say, but let me say it specifically. You did not become diabetic, type 1 diabetes, until you lose about 80% of the cells that make insulin in your pancreas. You do not develop Parkinsonism, even this final fine tremor, before you lost about 80% of these dopaminergic neurons in your brain. This machine is amazing. Our body is amazing. It has such a huge buffer, which is a way to say that we have a role in determining our health, but not absolute control. And so this should make people feel hopeful, realizing that there are actions that they can take, but also trust that with the knowledge, there will be new medicines that will address it when you did everything that you could and you still need help.
I love that. Well, thank you so much for coming in. I learned a lot. This is fascinating. And yeah, I don't think I'm ever going to think about mitochondria the same way ever again. So cool.
I find it cool. That's why I love my job.
I know. Well, I love your job. Thank you. I'm very excited for the life machines. I've got one last question for you, but before we get to that, where can people pick up your book and how can they connect with you? I don't know, on social media, maybe a website. How can they support your work?
So if they are in Northern California, we have an event at Kepler's bookstore in Menlo Park on the 14th of October. And otherwise, everywhere where books are sold, there are all sorts of forms online. I mean,
yeah.
What do you call it?
Amazon?
Yeah.
Yeah.
No. I'm tired. Anyhow, you can buy all sorts of forms on e-reading and so on. Not only hard copy.
Oh, yeah. Like Kindle and...
Thank you.
Audiobook? Did you do
Audiobook too.
Wow, amazing. Yeah.
But
the tour can be rough. I get it. It's
No,
draining.
it's not that the tour is rough. Everything is fine. And I'm not on social media.
Not okay. Good. You're better off.
I'm working.
She's better off.
But if people are interested in that, they can find the book also. They can check my Stanford website or Emmanuel. Right.
Beautiful. Well, the last question that gets asked everyone on the show: what does living a genius life mean to you?
Nice question.
Yeah.
It's really realizing that. First of all, taking care of your genius organelle mitochondria. There is a lot to do in that. But I think living genius life means to be aware and to try to grab happiness everywhere you can find. I would say this is a genius life, feeling happy.
Amen. Happy and healthy and wise. Love it. Well, thank you again. And yeah, guys, thank you so much for tuning in, for listening to this. Make sure that you're subscribed. We've got lots of epic episodes coming down the pike, and I will catch you on the next episode. Peace. Hey, if you like that video, you need to check out this one here, and I'll see you there.